Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 286. Page 286, and today is our lesson number 164. This is the second problem on the page. Is what we're going to do. Problem number 122. In problem 122, they tell us that B is the center of the small circle. B is the center of the small circle. Alright, so far so good. We are told that C is the center of the large circle. The question simply is, what is the area of the shaded region? And let's see exactly how they actually put it. Their question is phrased a little bit differently. It says in the picture above, A, B, C, D and E lie on a straight line. Alright, lie on a line. A is on both circles. Alright, so let's draw our circle. B is the center of the small circle, so let's draw a small circle here. The center is B. We are told that point A lies on both circles. Alright, fine. So here is a large circle. We are further told that C is the center of the large circle. So let's put it here somewhere. The C is the center of the large circle. So far so good. Which means A to C is the radius of the large circle, and A to B is the radius of the small circle. Alright, so far so good. They're calling it D, and then this point is E. If that point is E, and if C is the center of the large circle, then C to E must also equal A to C. And similarly, if A to B is the radius of the small circle, then B to D must be also the radius of the small circle. So I think we have gotten out everything that we could have. We have gotten out everything that we could have, and I think we're ready to do the problem. And the shaded region that they're talking about is this part right here, obviously. It's a very straightforward, simple question. All we have to do is find the area of the large circle, subtract the area of the small circle from it, and the leftover is the shaded region. Let's see what they tell us. In the first statement, they tell us that A to B is 3. Well, A to B is our radius of the small circle right here. A to B, they tell us, is 3. Well, if A to B is a small circle, if the radius of the small circle is 3, then the area of the small circle is pi r squared, or 9 pi. And they tell us, and they also tell us that B to C is 2. Well, that makes life easy. If B to C is 2 and A to B is 3, which means that the radius of the large circle, which is A to C, is simply 3 plus 2, which is 5. Which means the area of the large circle is simply pi r squared, pi times 5 squared, or 25 pi. 25 pi, and of course we can figure out very easily what the shaded region is. Shaded region is the difference of the two. So it's just 25 pi minus 9 pi, 16 pi is the answer. So the first statement by itself does the job. My markers are dying, so I need to open a new one here. I hate writing with the light markers because they're not very legible. There we go. And I should have taken this out ahead of time. That way I would not have had to put on this show of my virility as to how strong I am. I did it in less than 45 seconds. Okay, so that was the first statement. So in first statement by itself is enough. AD, BCE. Since the first statement by itself we just found out is enough, we know now that the answer cannot be B, C or E. It would have to be either A or D. Let's look at second statement. In the second statement they tell us the C to D is 1. C to D is 1. I'm going to erase all of this thing here. This part right here. That was from the first statement. C to D is 1. Alright. What else will I tell you? And D to E is 4. Well, that helps. If D to E is 4, if this distance is 4 and if this is 1, they just told us the radius of the large circle, because the radius of the large circle is C to E, and C to E equals C to D plus D to E, which we are just told is 1 plus 4 or 5. Hence we know the radius of the large circle, 5, and therefore the area of the large circle is simply pi r squared, just like before, 5 squared pi or 25 pi. Question is, how are we going to find out the radius of the small circle? Let's find out. Let's think about it for a second. Let's see what we can do. We know that C to E, we just found out that C to E is 5. We also know C to E is 5. We also know that, what else do they tell us? That C to E must also equal, this radius C to E must also equal A to C. A to C. In other words, from C to E is 5, which means A to C must also be 5. Are you with me so far? A to C is 5. And we know that C to D is 1. C to D is 1. Let's put it here. This distance is 5, because this distance is same as this distance. 1 plus 4. So we use this 5 from A to C is 5, and then C to D is 1. Combine them together, and A to D, this tells us, combine them together and it tells us that A to D must equal 5 plus 1, which is the diameter of the small circle. Now that we know the diameter of the small circle, we can figure out the radius of the small circle must be 3, and if we know the radius of the small circle, the area of the small circle must be 9 pi, same as before. Nothing to it. And therefore second statement, it turns out, it does also provide sufficient information to be able to answer the question. And therefore the answer is D. That's it. That was the end of it. Let's see what the next question is. I'm debating whether or not I want to go there. The next question is 123. Well, let's save it for later, okay? I'll see you tomorrow. Bye now.